Okay, try many 2617. This right here is for you. I saw your question on Reddit. How on earth is 1 minus cosine x equal to 2 sine squared of x over 2? Well, it's on my board right there, so it has to be true. But let me show you why this is true. So sometimes we can start with a trig identity from there, and then you can get to the identity that you want. And the deal is this. We are going to start with the double angle identity for cosine. So double angle of cosine is cosine of 2 theta. This right here equals cosine squared theta minus sine squared theta. And now I know some of you guys might be asking that why is this true, but that's another discussion. We can use this to get this result. Check this out. Notice here we have 2 sine squared. This is just minus 1 sine squared. Well, here we have cosine squared theta. We can actually replace this with 1 minus sine squared theta. So we can look at the double angle identity, cosine of 2 theta being equal to 1, and then minus sine squared and minus another 1, so that's minus 2 sine squared theta, like this. So it's quite nice, and maybe you already see like what's going on already. Now why did I still maintain the theta real though? Now let theta equal to whatever this is, right? Because you want to have that inside. So let theta equal to x over 2, and then plug in. So we get cosine of 2 times x over 2 equals 1 minus 2 sine square of x over 2. Quite nice, huh? So now this is what we can do. Let's go ahead, because I want this to be positive, let's go ahead and bring this to the other side. So let's go ahead and add 2 sine square of x over 2. So they cancel, but let me just put it down here, plus 2 sine square x over 2. So they cancel. But of course, we will also have to subtract this, which is cosine of what? 2 and 2 cancel. It's really just cosine x. So this and that can cancel. So right here, minus cosine x on both sides. So ladies and gentlemen, from here, we get the 2 sine square of x over 2. That is equal to the 1 right here. Also the minus cosine of x. Ta-da! That's exactly what we want. So hopefully this helps. That's it.